Hello everyone, thank you for watching my video today on geometric sums or geometric series. Before we get started, I would encourage you to pause this video and try the opener problems that are the first two slides. And when you're done with that, you can come back and check your answers with me. Okay, here is the first slide of the opener. Feel free to pause this as long as you need to check out your answers. And here's the second slide of the opener. All right, so in this video today, we're going to talk about finding the sum of geometric sequences. So this first formula we're going to look at here, important note here, is that this only works if it's one, a geometric sequence, and two, it's finite, okay? If it's infinite, there actually is another formula that we might be able to use. All right, with infinite arithmetic series, there's no formula because the answer is always going to be infinity. But with geometric sequences and series, there may be a formula we can use to find a geometric sum. So our formula for finite geometric sequences is right here. The sum of the first n terms is the first term times the ratio of 1 minus r to the n divided by 1 minus r to the first. So let's take a look at some problems and see if we can apply that formula here. So here we have a finite geometric series. I know it's geometric by how it looks here, and I know it's finite because it actually stops at a number. So we're going to apply that formula, S sub 12, because there's 12 terms here, of A1, so we got to figure out what A1 is. If we were to put 1 into here, into n, it would be 4 times 0.3 to the first, or just 4 times 0.3. So let's see what that would be. 6/5 times the fraction 1 minus r to the n over 1 minus r. Okay, so that's going to be 6/5 times 1 minus r to the 12th power divided by 1 minus r. That's going to be approximately 1.429 times 6/5. We get 1.714 as our sum. Number 2. So here again we have a geometric series. There are 11 terms this time. How do I know there are 11 terms? Well, the easiest way to find out how many terms there are is you're going to do the ending number, so which is 10, subtracting the starting number, then you're going to add 1 to that. That's the easiest way to figure out how many terms there are. So there are 11 terms here. So sum of the first 11 terms is going to be the first term. If you put 0 in, you're just going to get 3 times 1, which is 3, times 1 minus 1.5 to the 11 over 1 minus 1.5. So let's see what we're going to get here. So 1 minus 1.5 to the 11th divided by 1 minus 1.5 times 3. And our sum is going to be 512.985. Okay, on this page, it just says to find each sum and use a formula if possible to find each sum. And if not, we'll have to just figure out all the terms one at a time and add them together. All right, so number 3, Is it arithmetic, geometric, or neither? This is clearly arithmetic. So we can use the arithmetic formula, right? Which is S sub n equals n over 2 times a1 plus an. First, we have to figure out how many terms there are. So 74 minus 15 plus 1 is 60. So S sub 60 equals 60 over 2. And now the first term, so the first term is going to be a sub 15, and the last term, which is going to be a sub 60. So a sub 15 is 5 times 15 minus 3, that's 72. And a sub 60 is 5 times 60 minus 3, which is 300 minus 3, which is 297. So that's 72 plus 297. All right, so we have 30 times 72 plus 297, and our sum is 11,070. Number 4, this is clearly geometric, and it's finite, so we can use our finite formula. So how many terms are there here? 5 minus 0 plus 1 is 6. So 6 terms. The first term, if we put 0 in for that, so let's see here, a sub 1 would be 16 times negative 1/2 to the negative 1. So that would be 16 times negative 2. So our first term is negative 32 times 1 minus r to the 6th over 1 minus r. All right, so we got 1 minus negative 1/2 to the 6th divided by 1 plus 1/2, and then times negative 32. So sum of the first 6 terms here is going to be negative 21. Number 5, is this one arithmetic, geometric, or neither? This one is neither. So we can't use any formulas. So what we got to do then is just simply put all the numbers in one at a time and add them together. So if we put 3 in, we would get 6 back. If we put 4 in, if we put 5 in, if we put 6 in, and if we put 7 in. If we just add those together, 6 plus 13 plus 22 plus 33 plus 46, we would get 120. Number 6, arithmetic, geometric, or neither. This is geometric, and it is finite, so we can use this formula. How many terms are there? 9 minus 2 plus 1. There are 8 terms. So sum of the 8 terms here. The first term, if we put 2 in, we would get 2 times 3 squared, which is 2 times 9, or 18. So our first term is 18 times 1 minus r to the n over 1 minus r. All right, let's see what we got here. 1 minus 3 to the 8th divided by negative 2 times 18, 59,040. Number 7, arithmetic, geometric, or neither. Let's see. Well, we're adding 6. So this looks like it's going to be arithmetic. So let's find our nth term. 5 plus n minus 1 times 6. 5 plus 6n minus 6. 6n minus 1 is our nth term. So our summation is going to be n equals 1 of 6n minus 1. We don't know the last term yet here, so let's set 443 equal to this. And 444 divided by 6 gives me 74. All right, so then our sum of the first 74 terms is going to be 74 over 2 times the first term, which is 5, plus the last term, which is 443. So it's 37 times 448 16,576. And number 8. So let's see what kind of formula this is. We're adding 5, adding 10, so it's not arithmetic. But we are going to multiply by 2, multiply by 2. So this is geometric. All right, so if I wrote out the geometric formula for this one, it would be 5 times 2 to the n minus 1. So my summation is going to be 5 times 2 to the n minus 1, starting at 1. And now we got to figure out what this is, what term this number is. All right, so if we divide 40,960 by 5, we get here. Now there is a method to solving this equation using logarithms, but we have not learned logarithms yet this year. So the best we can do is to start taking a guess. 2 to what power would give us that? So 2 to the 13th power. So 2 to the 13th power would give us that, which means 13 must equal n minus 1, so n is 14. Like I said, we will learn another method to solving that equation soon, but for right now, that's the best we can do. Okay, so now we can set up our summation of the first 14 terms. The first term is 5 times 1 minus r to the 14th over 1 minus r. And let's see what we get here. 1 minus 2 to the 14th divided by negative 1 times 5 is 81,915. Okay, so earlier in the screencast here, we've talked about what if it's infinite? And sometimes we can still find the value of that series. All right, so if a geometric sequence of terms converges to 0, we can find the sum of this infinite geometric series. Start with this formula we already know here. And if we were to say that we're looking for infinite terms here, we would get a sub 1 times 1 minus r to the infinity over 1 minus r. Okay, 1 minus r to the infinity. Now remember, r could be any number. If r is bigger than 1, then this numerator is going to go to negative infinity. There's nothing we can do about that, or positive infinity, depending on r. Okay, but if r is less than 1, then this is going to go to 0. Which means my numerator is just going to be 1 minus 0 or just 1. So then I can multiply 1 times a1, and my numerator just becomes a1. So if the absolute value of the ratio is less than 1, this is the formula we can use for an infinite geometric series. If r, let's write this down here, if the absolute value of r is greater than 1, we say the series diverges. And basically the answer is going to be infinity or negative infinity, and we can't actually find a numeric answer. Okay, so let's take a look at a couple of these. Find the sum of the geometric series, basically if possible. So here's an infinite geometric series. How do I know it's geometric? Look at the formula. How do I know it's infinite? Because there's an infinity right there. So is the absolute value of r greater than or equal to 1, or sorry, greater than or less than 1? So the absolute value of 1/2 is less than 1. So this series converges, which means we can use this formula here, a sub 1 over 1 minus r. So the sum of the infinite terms would be the first term. If we put 1 into there, we would get negative 5 times 1/2 to the 0, or negative 5 times 1, or just negative 5. So negative 5 over 1 minus r. So negative 5 over 1/2, or negative 10. The second one. This is a geometric series. It's infinite. So we have to look at r. Absolute value of 4/3 is greater than 1. So this this series then diverges, and it's going to go to infinity. So the answer to this is going to be infinite. C, we can clearly see this is a geometric series. We're multiplying by negative 1/3. So my nth term formula would be 90 times negative 1/3 to the n minus 1. So it's a geometric series. It's infinite because of these dots telling me it goes on forever. So let's look at r. The absolute value of r is less than 1. So therefore, this converges to some number. Now we can find that number. So the sum of the first infinite terms would be a sub 1 over 1 minus r. So it's 90 over 1 plus 1/3, which is 4/3, which is 67.5. Or if you want to give me that in fraction form, that's fine too. Okay, last one. This is also a geometric series. Let's see what we're multiplying by. So multiply by 2, multiply by 2, multiply by 2, right? So if I was writing out this series, it would be 1/4 times 2 to the n minus 1, which means the absolute value of r, the absolute value of 2, is greater than 1. And since this is infinite, that means this series diverges, and the answer is going to be infinity. All right, that is it for our lesson here on geometric series. I hope you enjoyed the video today, and we will see you next time.